Hey class, this is the screencast for the notes for worksheet number 4. But before we get to worksheet number 4, I'm going to talk a little bit about the 4 types of reactions. Now you guys must know that there are hundreds, even thousands of reactions or millions of reactions out there. But for the ones that we're going to look at, we can categorize those reactions into 4 main types. Okay? So let me introduce those types to you. So you can see I have some letters on the board here. The first one is called synthesis. So a synthesis reaction is when we have an element with one capital letter, that's how we know it's an element, added to another element. Okay, now the element is typically, one of them is a metal and the other one is a non-metal, because when they come together they form an ionic compound. So on the right hand side we have our compound that has more than one capital letter, okay, and that compound, the beginning part is positive, which is usually the metal, and the ending part is negative, which is usually the non-metal. So that's the pattern we're going to use. So an element plus an element equals a synthesis reaction, and it equals a compound. A very good or easy example would of course be when we take hydrogen and we add it to oxygen here. Now I know that hydrogen is not a metal, it is a non-metal, but because it gains a positive charge to form water, and this is a pretty common reaction, then obviously this is what a good example of a synthesis reaction is. Okay, I'd like to give you the other 3 types of reactions so that you can rewatch this if you need like a refresher on what they are. So the D is decomposition. Decomposition is pretty much the same thing but in reverse than synthesis. Notice that you have here, I'm going to erase some of this. Notice that you have here, you have an element plus an element for synthesis, but here it's just a compound. Sometimes you may see, not sometimes, very often you're going to see plus heat. That says heat there. So you still may see a plus sign for decomposition, but that plus sign followed by heat will always mean it's a decomposition reaction. And what happens for a decomposition reaction is you start off with a compound that has more than one capital letter. Okay, that's why I have A and B together. And then that yields 2 or more things. And that's what a decomposition reaction is. Now they don't have to be elements that they equal on the other side. It can be compound and a compound. As long as it equals more than one thing, this is a decomposition reaction. So on the left hand side you will see just one compound, or you will see one compound plus heat. Something like copper sulfate plus heat yields, and then it would be CuO plus SO3. Okay, do not worry about how to get these compounds on the other side. Okay, I'm simply showing this to you so you can see that there's one compound here plus heat, and that's what a decomposition reaction is. Okay, that's my example of a decomposition reaction. Okay, so the other ones that we're going to talk about, and I'm not going to give you examples of these two for single displacement and double displacement, but I will show you what's going on. Single displacement means the single part is referring to just an element, and if that element is a metal plus a compound, where we have a plus and a minus here, then that metal, this by the way stands for cation. This is what we call a cation single displacement, because that metal gets a positive charge on the right hand side, and that's why we call it a cationic single displacement. I should put that like that. Single displacement. There we go. Okay, so the metal here plus the compound, the A switches places with the other positive part, which would be B, which is why you see AC on the other side and B is by itself. And we'll talk more about that later on. What if you have, though, an anionic single displacement? That means that your A is a nonmetal. And because nonmetals, just like up here in the negative part, tend to form negative ions. Instead of replacing B, A, the nonmetal, will replace the other nonmetal or the other negative part, okay, and the C, which is why you see B, A, and then plus C. So a metal cationic single displacement and a non-metal anionic single displacement. Okay, now that looks very confusing, but we're going to talk more about that later on. The double displacement is even easier to understand because here we have a compound plus a compound. So with a compound plus a compound, that means that I have, let me write this down for you. So this is what's called a double displacement. You can, of course, look all of this stuff up on YouTube and watch some videos as to how it works. And they probably have better screencasts and better graphics to show you exactly how it works. But in our typical ionic compound, A is a metal and B is a nonmetal, C is a metal and D is a nonmetal. And then what happens is that the two nonmetals switch places. And that's it. And that's why you see on the other side here A and D and C and B. And that's a double displacement reaction. And you will always get this pattern every time in the products. If we're looking at just the reactants, because you have to figure out what the products are, then we have a scenario that looks like this. So here we have the types of reactions, and again, that's synthesis, okay? And then we have our element hydrogen plus our other element oxygen, like this, and then it yields like whatever. And this is a good example of how you figure out that it's a synthesis reaction. Compound, just like it can be plus heat. Okay, so that would be CuSO4 is copper 2 sulfate, and that decomposes into what we saw before from the other example. But this is an example of one compound plus heat, and that's what a decomposition reaction is. For an element plus a compound, it might be something like, let's see, what would be a good example? How about cobalt plus, let's stay with copper sulfate, like that. And then cobalt would kick out the copper on the other side. But here we have an element with one capital letter. That's what this is, one capital letter. And here we have a compound with more than one. I have a C, an S, and an O are all capital letters, which means that this is definitely a compound. So element plus a compound. Then we can have a compound plus a compound. Yields. Notice we have more than one capital letter here and more than one capital letter here. So these are two compounds. We have our plus part, our minus part, our plus part, and our minus part. And then we just simply take the two negatives and switch them. And that's a compound plus a compound, which is double displacement. All right, stay tuned for the rest of the notes for sheet number 4 and examples.